The goal of each of these videos is to show you how to attack a free response question and how to do it quickly and efficiently. And part of it is sort of thinking as you're going and reading carefully. So this is 2017 question number 1. I'm not going to give you the answers, but I'll give you guidance if you need. I strongly suggest you try to do the question on your own and then come back here for guidance, and then eventually look up the answers to check that you got them right. I will not be giving answers here. Right? The calculator work and things like that, that's on you, and you can always look up the answers. And remember, the answer keys they give you are just they're a grid, they're a guidance for the reader. All right. If you think it requires more, I'll tell you at some point when we get closer what I would think they are expecting. All right, let's just start with this question right here. So the first thing it says, you must show your work. So that's an obvious no-brainer, but figured I would read that to you, and you must pay attention to sig figs. Sig figs usually only counts in one question from what I'm understanding on the AP exam. So don't drive yourself crazy about sig figs. Okay. However, you could at least be aware. So in this question, what do I notice right off the bat? I've got an equation, a chemical reaction, and the chemical reaction has nothing but gases. If I've got nothing but gases in there, I've got two possibilities. And this is the way I want you. As soon as I see that, I'm thinking it's either going to be an equilibrium question or it's going to be a Pivnert question. And then I start reading. It says carbon tetrachloride can be synthesized. The chemist runs and it gives you a temperature and it gives you a volume. And then in line A of the question, it then gives you a pressure. That's screaming Pivnert. And it says how many moles. So that guides you. This says, okay, I'm definitely going to be using Pivnert. And then they want you to find out the grams. Now, the second part of this question, okay, so they're going to get the moles of Cl2, one substance, that are initially in there. And then they ask you how many grams of CS2 are required. Now, this is a question that involves two steps, right? So this is going to be a little bit of stoichiometry because for every 3 moles of chlorine, you're going to make 1 mole of CS2. And so you're going to have to use the moles that you get in the first time and use a little stoichiometry and then convert to grams. Again, I'm not doing it for you. I'm just giving you the guidance, all right? Now, it then says at 30 degrees Celsius is thermodynamically favorable, but there's no reactions observed. And then at 120, the reaction does get observed. Now, this is really sort of about thermodynamics, but they're showing you a Boltzmann distribution. And they're showing you the activation energy, and they're talking about collisions, right? So it says, why are collisions more effective at the higher temperatures? You should know that from 10th grade. I'm not going to give you the answer, but there's 2 things you need to write when you talk about collisions and their increase in temperature. All right, and I'm not going to tell you. The second part of this question says, the graph below shows a distribution of collision energies. Draw the second curve on the graph that shows the distribution for reactant molecules at 30. So this makes you have to read things very carefully. So they're telling you this is 120 degrees Celsius. What's 30 degrees Celsius? Now, the idea of 30 degrees Celsius is you shouldn't have molecules, essentially, or very many molecules that have the activation energy. I'll give you the hint. You're not going to flatten the curve. You're going to do the opposite. All right. Now, then it gets into molecular structure. Now, I kind of saw that coming too because I saw a bunch of non-metals, and I said, how are they going to make this question a 4 or 5 part question? Well, they do a Lewis structure thingy. Only hint I want to give you on this one is don't automatically try to do an expanded octet unless you have to. All right, unless you have extra electrons, assume no expanded octet. All right, and I'll give you the other hint would be to be aware of the idea that a lot of times the molecules they give you follow the rules. Like group 16 elements usually make this number of bonds. Group 17 make this number of bonds. Group 15 usually make that number of bonds. So that might be a good helper. Now, then they ask you about bond angles. Okay, in the SCl2 that you drew in part C. So, and this is the thing, it will be a follow through. So if you decide that, this is the answer, and by the way, I'm giving you a wrong answer, you decide that's the structure, okay? I'm literally giving you a wrong structure on purpose. Then you would be like, okay, it says, what are the bond angles? Now, assuming what you did around each of these S's is the same, because there's 1, 2, 3 domains the way you drew it, you're going to get angles of like 120 degrees around each of them. if you drew different things around it, I'm erasing now. If let's say you decide that there's going to be this, and again, this I'm drawing things that are wrong. Okay, if you decide that, then around this one you can always have the two dots there. This is going to be 120, and around here it's going to be 180 because you only have two domains. So they'll do follow through. So if you really mess up the first part, you can then get an answer for the second part that's consistent with your answers to the first part. All right, remember, do Lewis structures the way I taught you on the video. Try single bonds first. If you end up with extra electrons, you have an expanded octet. If you're short of electrons, you're going to have to put in some double bonds and things. All right, and again, if the best thing you can do is something where the formal charges are all zero. So you can keep that in mind as well as a guidance. All right, CCl4 can also be produced by doing this. So they give you another reaction, right? And in this one, it says after the completion of reaction, the chemist successfully separates CCl4 from the HCl by cooling the mixture to 70 degrees Celsius, at which temperature CCl4 condenses while the HCl remains in gas state. This question is about a phase change. Okay, it's about a physical change. And the substances they're dealing with are molecular substances. So if you're not seeing that those are molecular substances, everything in this question was about molecular substances, and then they ask you about intermolecular forces. Now, you need to mention all of them. So I'll give you one thing, right? It said you're going to have to mention the different forces in each of the molecules. London dispersion forces are going to be in every molecule. So if you don't mention those, you're losing points, okay? The question is what other IMFs are present. And the relative strengths are based upon the melting point and boiling point. So again, a quick reminder, if something condenses or at a higher temperature, that also means it boils at a higher temperature. If it requires a higher temperature, IMFs are strong. Remember, almost all the physical properties are directly correlated with IMFs except for vapor pressure. That's the first question.